Hello, this is Wade Kariniemi and I'm working on the grocery store application with Jezreel, Kevin, and Reman.
The application that our group has decided on implementing is an online grocery store web application. This web app will use HTML, CSS, and JavaScript for all of our front-end functionalities, such as site design and UI logic. The database management system we have decided to use is MySQL, which is known as one of the most popular open-source relational SQL database management systems. This web application has the following main functionalities that will need to be implemented in order to achieve full functionality of the site, which are: customers should be able to browse through the library of the site's products, add products to their cart, and check out their order. In addition to these core functionalities, customers should also be able to refund purchases that they have previously made. The stock should automatically order more products when the quantity of a product hits a certain threshold. Finally, the site will also have a type of transaction processing system which will, when the checkout button is pressed, process the transaction and send the relevant purchase data to the database to be stored.
In order to make use of a database effectively, the relationships between the entities and how that translates to the software you will be using is essential, even more so when working with a web application. This diagram attempts to illustrate the relationships between the key parts of the grocery store system. There are two main entities to keep track of: customer, products. A customer will have two attributes with a session ID as the key. They will be able to add products to an online shopping cart and see what their subtotal items currently on the cart. They will be able to check out these items or purchase these items from the cart as well. A cart will only be composed of products. For this to happen, we need to have a way to identify different products. They will have a name and a price with a name as a key. Other attributes include a sell-by date and meat type. A sell-by date will be used for products such as produce, which has an expiration date. Meat type will be used to identify products such as beef or poultry. These two attributes can be nullable. Returns will be supported by purchase. That is to say, in order to make a return, you will need a transaction ID, which is stored in the sales history, to return all items within a single purchase. The sales history will have a transaction ID, which will act as a key, and a date of when the transaction occurred. Products are made by a company, and this company supplies these products via orders in order to maintain a set stock. Stock will have an attribute for amount per product and the product name, which is the key. Orders are made to replenish the stock. Orders will have the amount to order products and a date which the order was sent.
As stated previously, we will be using MySQL for our database management system, and HTML, CSS, and JavaScript for the front-end functionalities. In our system, there will be three main actors: the transaction processing system, which will process orders and keep track of the transaction ID and the list of items bought in the transaction, as well as sending that information to the database. There's also the customer, which will be able to add products to the cart, manage and edit their cart, check out their purchase, and if needed, refund a previous purchase. The last actor in our system is the warehouse or supplier, which will receive a product order request when the quantity of a certain product in the grocery store is running low, and will automatically accept the request and promptly replenish the store's stock of that certain product.
Continuing on with our requirements, we have a few use cases to demonstrate the actors in our system as well as the actions they will take. First off, we have the Transaction Processing System use case, TPS for short. The TPS will manage all actions pertaining to orders within the grocery store. This includes any purchases as well as any returns made by customers. So here we have the TPS actor, and they do the process returns and process order actions. And now here we have the customer use case. The customer actor has a few actions, the first being adding products to their cart. While the customer is browsing through the store, they may add items they want to their cart before they officially make the purchase. Next, we have the checkout action. This is when a customer is ready to purchase those items. The action will remove all items from the customer's cart, request payment from the customer, and if they pay, then they will be given the products officially. The last action is request return. If a customer realizes they have purchased the wrong product or no longer wants the product, they may return the item to the store within the same day. Every purchase has a transaction ID attached to it to ensure that customers only return items that they did in fact purchase.
Our last use case involves warehouse and suppliers. The supplier will supply the product to the grocery store. Thank you, and I hope you enjoyed the presentation.